Today we are going to discuss Edexcel IAL Chemistry October 2019 paper 2. We have already discussed the section A of this paper. Now today we are going to discuss section B. If you want the link for section A of this paper, you can see and you can find out in the description box of the video of the today's part as well. Now part B, section B, question 16. Write an equation for the reaction of calcium with cold water. So when that calcium reacts with cold water, it forms calcium hydroxide. So calcium reacts with water to form calcium hydroxide. You need to write the state symbol for this, and hydrogen gas. Then you will balance this equation. Okay. Now move on to the next question. Explain why a saturated solution of calcium hydroxide is more alkaline than a saturated solution of magnesium hydroxide. You know, if there are more concentration of hydroxide ions, it means the solution is more alkaline. So the saturated solution of calcium hydroxide is more alkaline due to the increased concentration of hydroxide ion, because the concentration of hydroxide ion is greater. Because calcium hydroxide is more soluble than magnesium hydroxide. You know, the solubility of group 2 hydroxide increases down the group. Now part C. Dilute hydrochloric acid was added to the solution and the gas was given off. A solution was tested for the presence of carbonate ions. Okay, so in carbonate ions, then you will add the hydrochloric acid, because you need to write the ionic equation. So hydrogen ion comes from hydrochloric acid. They are saying that you don't need state symbol. It will form carbon dioxide gas and water. So this is the ionic equation. Now, when hydrochloric acid was added to the solution and the gas given off was bubbled through lime water. So the gas given off is carbon dioxide, and when we pass this gas through lime water, aqueous calcium hydroxide, a white precipitate form. Write the equation for the formation of precipitates. So when carbon dioxide passed through lime water, carbon dioxide gas passed through lime water. What is lime water? It's calcium hydroxide. It's aqueous. It will form the white precipitates of calcium carbonate, which are insoluble precipitates. So the lime water turns milky due to the presence of calcium carbonate precipitates. Now, magnesium hydroxide can be used to neutralize hydrochloric acid in the stomach. Now, calculate the minimum mass of magnesium hydroxide needed to neutralize 0.15 moles of hydrochloric acid. Now, here they have given you the moles of hydrochloric acid. You know, the ratio of magnesium hydroxide and hydrochloric acid moles is 1:2. So, if the moles of hydrochloric acid is 2, the magnesium hydroxide moles will be its half. So the moles of magnesium hydroxide will be equal to 0.15 divided by 2, 0.075 moles. Okay, now you know the MR of magnesium hydroxide. you need to calculate that, and if you will calculate that, it's equal to 58.3. How can you calculate? Magnesium is 24, oxygen 16 into 2 plus hydrogen 1:2, so it's 58.3 if you will take the exact figure. So now we need to calculate the mass of magnesium hydroxide. So mass of magnesium hydroxide is equal to 0.075 into 58.3 is equal to 4.4 grams. So this is the correct answer. Now question number 17, A part 1. Write the name of the compound. The first compound given you is butane, 1-ol, primary, basically alcohol, and boiling point is 117. The second skeletal formula given to you is you need to basically count the carbons, 1, 2, 3. On first carbon OH is attached, and on second carbon methyl is attached. So what will be the name? 2-methyl, because the methyl group is on second carbon. This is a methyl group, and overall there are 3 carbons. So propane 1-ol, on the first carbon OH is attached, and because the alcohol group OH is attached on the first carbon, it is called a primary alcohol. Now next, the alcohol group is attached on the second carbon, so this is basically the secondary alcohol, and the name is 1, 2, 3, 4. So there are 4 carbons, and on the second carbon OH group is attached, so it is known as butane 2-ol. And now you need to draw the structure of 2-methyl propane 2-ol. So this is two methyl propane 2-ol. First carbon, second carbon, third carbon. On second carbon, methyl as well as OH group is attached. And you know, the OH group is attached on the carbon, which is a tertiary carbon. So you will classify the alcohol as a tertiary alcohol. Explain the difference in the boiling temperature between butane 1-ol and 2-methyl propane 2-ol. Although the molecular formula of both are the same, but the difference is in the structure. So as you know that the long chain hydrocarbon, straight chain hydrocarbon has strong intermolecular forces as compared to the branched. So due to the presence of higher intermolecular forces, more points of contact, basically the boiling temperature is high. So you can write that the London forces are stronger between straight chain in butane 1-ol and so because of the higher, because it has a higher surface area, because it has high, or you can write that it has a greater surface area. More points of contact. So butane 1-ol has high boiling temperature. Now complete the diagram to show the strongest intermolecular forces between two molecules of butane 1-ol. Include the intermolecular bond angle. Okay, in between the two molecules of butane 1-ol, the strongest intermolecular forces will be hydrogen bond due to the presence of OH group. So you need to draw the hydrogen bond, and you know oxygen has a lone pair of electron, and that lone pair of electron forms hydrogen bond with hydrogen of the other molecule of butane 1-ol. This is the other molecule of butane 1-ol. Okay. So you need to draw the structure. Okay, now you can see here that the bond between oxygen and hydrogen is 180 degree. So you need to show the bond as well. Now, question number 2, part B. Part B. Complete the equation for combustion of butane 1-ol. State symbols are not required. So you need to balance the equation. So 6 and 4 and 5. Just simple balance the equation. Now move on to the next question. Calculate the value of enthalpy change of combustion of butane 1-ol using the equation and the mean bond enthalpies in the table. So you need to find the enthalpy change of combustion, and the formula is the bond breakdown minus bond form. So first you calculate the energy involved during the bond breakdown. Now look at the equation. Here in the reactants there are, in butane 1-ol, there are bonds of carbon and hydrogen. And how many bonds of carbon and hydrogen are here? 9. One bond of oxygen and hydrogen, and 6 bonds of oxygen and oxygen. So one bond of hydrogen and oxygen plus 6 bonds of oxygen. So if you calculate the value 9, the value of carbon hydrogen bond is 413 plus hydrogen oxygen bond 464 and oxygen oxygen bond 498. So the total value is equal to 8568 kilojoules per mole. Now energy involved in bond formation. Here look at the equation. Carbon oxygen bonds, so in each molecule there are 2 carbon-oxygen bonds, and there are 4 molecules. So it means there are 8 carbon-oxygen double bonds in products where the bonds are formed. Each water molecule contains two hydrogen oxygen bonds, and there are 5 water molecules, so the hydrogen oxygen molecules are 10. So 8 into 805 plus 10 into 464. So the total value is equal to 11,080 kilojoules per mole. Okay. Now we have the formula: bond breakdown minus bond form to calculate the overall enthalpy change of the reaction. So 8568 minus 11080. So the answer is negative 2512 kilojoules per mole. So this is the calculation of enthalpy change. Okay, and the negative sign shows that energy is produced. Okay, now move on to the next part. A data book value of the molar enthalpy change of combustion of butane manure is minus 2670 kilojoules per mole. Give 2 reasons for the difference. Now, third part, a data booklet value of a molar enthalpy change of combustion of butane vanol is minus 2670 kilojoules per mole. Give 2 reasons for the difference between this value and the value calculated in B2. So there's a difference in the value which is given the data booklet and the value which is calculated. The reason is that the mean bond enthalpies don't refer to specific values. They are basically the averages for different molecules and in different environments. So mean bond enthalpies do not refer to specific compounds such as butanol, which is given here. Mean bond enthalpies are averages mean for different molecules, bonds in different environments. Now, biobutanol has some advantages over bioethanol. Now, you need to calculate the energy for the combustion of biobutanol. The density is given here, it's 0.810. Density is basically mass over volume. So, the density is given here 0.8. First, we need to calculate the number of moles. Number of moles is equal in 1 centimeter cube. So mass is 0.810 of butanol. MR of butanol C4H9OH is equal to 74. So number of moles is equal to mass over MR. Number of moles is 0.010946 moles. So these are the number of moles. Now you need to calculate the energy per centimeter cube, produced per centimeter cube. So you need to multiply the number of moles by the enthalpy change of combustion of 1 mole of butanol, that is minus 2670. So you will have value 29. So this is the answer. Now move on to the next part of this question. Biobutanol can be mixed with petrol in any proportion, whereas bioethanol cannot. Petrol is a mixture of liquid alkanes. Explain why petrol is more miscible with biobutanol than with bioethanol. Biobutanol has a longer chain. It has more carbon, 4 carbons, whereas bioethanol has 2 carbon in the carbon chain. So because biobutanol has a longer hydrocarbon chain, more electrons, so stronger London forces between biobutanol and petrol as compared to bioethanol and petrol. So you can write the reasons that biobutanol has a longer hydrocarbon chain than bioethanol and have more electrons than bioethanol. So more stronger London forces are present between biobutanol and petrol as compared to bioethanol and petrol. This is from chapter 7 of Edexcel IAL Chemistry book. Now move on to the last part of this paper, sections. Not the last part, let's move on to question 18. Two different processes can be used for the production of chloroethane, which is the monomer of the manufacture of polychloroethene. Okay, now the mechanism is given here. Identify each mistake given the correction that should be made. So you need to identify the mistake. Okay, now the first mistake you can see here that the arrow is pointing towards the carbon-carbon bond. This is the mistake because the arrow should be from carbon-carbon bond. The direction of the arrow is wrong. Okay, so this is the first mistake. The second mistake is, you can see here in the intermediate, a partial charge is given on the carbon. It should not be a partial charge, it should be a full positive charge. So you need to write these mistakes. The arrow pointing to the carbon is incorrect. And what is the correction? That the arrow should be pointing away from the bond. Okay. Now, mistake 2. The partial charge on carbon in the intermediate is incorrect. It should be a full positive charge. Then write the overall equation for process A and use it to calculate the percentage atom economy by mass for the production of chloroethene. So when ethene reacts with chlorine, it will form chloroethane and hydrogen chloride. Okay, so mass of chloroethene is 62.5, and this is the mass of chloroethene. 1 mole of chloroethene is equal to 62.5, and if you will look at the total mass of products, it's 99. So and because you need to calculate the percentage economy, so you will multiply this with 100. So the percentage atom economy is equal to 62.5 divided by 99 into 100, that is 63.1%. Process B, this is an alternative process, and here the chloroethene is obtained by reacting ethyne with hydrogen chloride. Now state how the process A compares to process B in terms of percentage atom economy by mass and environmental impact of each process. No calculation is needed. You can see here in the process B only one product is produced. Okay, so it means the atom economy here is 100%, because only the desired product is produced, no extra product is produced. So atom economy is 100% here. Whereas the atom economy of the first process is 63. So now state how process A compares to process B in terms of percentage atom economy by mass and environmental impact of each process. So by mass, if you look by mass, the process B is having the atom economy of 100%, whereas process A has an atom economy of less than 100%. Okay, uh, and if you will look from environmental impact of each process, then in process A, hydrogen chloride gas is produced, which is toxic, corrosive, or if you look at the process B, the catalyst is used, which is mercury 2 chloride, which is highly toxic. So in this way you can compare both the processes. This question is of 2 marks. So in the first mark you need to write about the atom economy comparison, and the second you need to talk about the environmental impact of each process. So atom economy of process B is 100%, whereas process A is less than 100%. In process B, mercury 2 chloride is used as catalyst, which is toxic, or you can say highly toxic. In process A, hydrogen chloride gas is produced, which is toxic and corrosive. Okay, so these are the reasons. Process B involves gas molecules reacting at high temperature in the presence of a catalyst. Explain the effect on the rate of the reaction of increasing the temperature and using a catalyst in process B, referring to a label diagram of Maxwell-Boltzmann distribution. Okay, so you need to show the effect of increasing temperature and the catalyst in process B, and you need to draw a label diagram for by referring to the label diagram. So first you need to draw the label diagram and draw the axis. X-axis energy, on y-axis number of molecules with given energy. Okay, so at temperature 1 and this is the and for T2 so this is the temperature and this is T1 is higher than T2, so this is the activation energy. So you can see here that increasing temperature increases energy of all the molecules. So this results in greater corrosion, so rate of the reaction will increase. And if you add the catalyst, it provides an alternative pathway, which so more molecules have the energy which is equal to the activation energy. So on the x-axis, number of molecules with given energy. On y-axis, the number of molecules with given energy, x-axis energy, and if you can draw again. So this is the activation energy with catalyst. Okay, so by adding the catalyst, more molecules have the energy which is equal to the activation energy. So you need to write the points that activation molecules, increasing temperature increases the energy of all the molecules. As a result, the collision will increase, so the rate of the reaction will increase. Adding the catalyst provide an alternate pathway which lowers the activation energy, so more molecules. Question number 13, part A. Complete the dot and cross diagram to show possible arrangement of outer shell electrons in the molecule of sulfur dioxide. So you need to draw the dot and cross diagram. You know, oxygen is in group 6, so it has 6 electrons in the outermost orbit. Sulfur is also in the group 6, so it also has 6 electrons in the outermost orbit. So basically, um, 2 electrons of each oxygen forms a covalent bond with 2 electrons of the sulfur. In this way, 4 electrons of sulfur are shared with 4 electrons of oxygen. So this is sulfur dioxide. Now the value of bond angle is 120 degree. Now this part is related to titration. The mean titer is 21 centimeter cube. Okay, the titration is between the levels of sulfur dioxide in the atmosphere can be measured by collection and titration with sodium hydroxide. Air contains sulfur dioxide is bubbled through a hydrogen peroxide solution. All the sulfur dioxide reacts to form 40 centimeter cube of dilute sulfuric acid. Okay, when sulfur dioxide is passed through hydrogen peroxide, it is converted into basically sulfuric acid, and the volume of sulfuric acid is 40 centimeter cube. Okay, then a pipette used to take out 10 centimeter cube of sulfuric acid from that 40 centimeter cube of sulfuric acid volume, and the titration is done against sodium hydroxide. They have given us the concentration of sodium hydroxide here. This is the concentration of sodium hydroxide. Okay, and the volume of sodium hydroxide, the titer. Now, give a reason why a further titration was not attempted. Okay, because they already got two concordant readings, so there is no need of performing the titration again, as the two concordant titers had already obtained. Now calculate the number of moles of sulfuric acid in 40 centimeter cube of solution X. Okay, now you need to find the number of moles of sulfuric acid. For that, first you need to find the number of moles of sodium hydroxide because the concentration and volume of sodium hydroxide is given. So we will calculate the number of moles of sodium hydroxide. We have the concentration of sodium hydroxide given in the question, that is 0.005, and we have the volume here through title 21 centimeter cube, 21 divided by 1000 in order to convert it into decimeter cube. So the number of moles 1.055 to power minus 4 moles. So these are the number of moles. Now you know that 1 mole of sulfuric acid react with 2 moles of sodium hydroxide. So if you want to calculate the number of moles of sulfuric acid, that will be half of the sodium hydroxide, and we are calculating that in 10 centimeter cube sample because we took 10 centimeter in the conical flask and then we did the titration with sodium hydroxide. So if you will divide that with 2, then the half will be 5.275 test power minus 5 moles. So these are the moles of sulfuric acid. Now the moles of sulfuric acid in 40 centimeter cube, because you have calculated the moles in 10 centimeter cube, in 40 centimeter cube. So it means we have calculated in 10 centimeter cube. If you will calculate 40, it will increase 4 times. So you will multiply this with 4. And then you will get the answer, the moles. Now you have the moles of sulfuric acid. Now next part, reduce the number of moles of sulfur dioxide bubble through hydrogen peroxide solution using the answer B2 and the equation. Okay, now you need to find out the number of moles of sulfur dioxide. Look at the equation, 1 mole of sulfur dioxide forms 1 mole of sulfuric acid. So you have the moles of sulfuric acid which will be equal to the moles of sulfur dioxide. So the moles of sulfur dioxide in 40 centimeter cube will be equal to 2.11 10 to power minus 4. The same moles as that of sulfuric acid. Now, the air containing sulfur dioxide was bubbled through hydrogen peroxide solution at a rate of 10 decimeter cube per minute for 30 minutes. Calculate the concentration of sulfur dioxide in the air in parts per million by volume. Okay, so you need to calculate the concentration of sulfur dioxide in air in parts per million. Okay, so here the volume of air used flow rate is equal to 10 decimeter cube per minute, and the time here is 30 minutes. So the total volume is equal to 300 decimeter cube. Now you need to find out the volume of sulfur dioxide. So for that, you will convert the moles of sulfur dioxide into volume by multiplying this with the molar volume, 24 decimeter cube. So you will get the volume of sulfuric acid 0.005 decimeter cube. This is the volume of sulfuric acid. Now you need to do the parts per million calculation. So volume of sulfuric acid divided by total volume multiplied by 10⁶. So you get the answer 16.9 parts per million. Now next part. During a volcanic eruption, hydrogen chloride gas is also released into the upper atmosphere, which in turn produces some chlorine free radicals. Chlorine free radicals react with ozone. Drive the overall equation for this reaction of ozone. State symbols are not required. Okay, so here you need to write the overall equation. This is ozone, O3. This is the conversion of ozone into oxygen. Now give two reasons why the presence of a small amount of chlorine free radicals in the upper atmosphere causes a large decrease in the amount of ozone. Yes, because even if a small amount of chlorine free radicals are present, the chlorine free radicals is regenerated. So many ozone molecules decompose for each free radical formed. So chlorine free radical causes a chain reaction. So you can write the chlorine free radicals are regenerated many ozone molecules decompose for each free radical form. So you can imagine how harmful chlorine free radical is. So chlorine free radical causes a chain reaction. Okay, now move on to part D. Sulfur dioxide is converted to sulfur trioxide in the upper atmosphere in the presence of ultraviolet rays. Show by use of all the relevant oxidation number that this is a redox reaction. Now you know that the reaction which oxidation as well as reduction takes place, that is called a redox reaction. Here you can see that the oxidation number of sulfur in the reactant is +4 and it changes into +6. So oxidation number increases, it means the sulfur gets oxidized, oxidation takes place in sulfur, where if you will look at the oxygen in O2, the oxidation number changes from 0 to -2 here in the products. So the reduction takes place. So overall this reaction is called redox reaction because one species gets oxidized and other gets reduced. Now draw an enthalpy change diagram to show the enthalpy change for this reaction, and because this is an exothermic reaction, So in an exothermic reaction, the energy of the reactants is greater than the energy of products, and extra energy is released as heat energy. So you can draw the energy level diagram. We will write the products here. The energy released minus 200 kilojoules per mole. This is a straight line. So basically, this is the energy level diagram of an exothermic reaction. Now move on to the last question of this paper. Assess the effects of both gases on global temperatures after the volcanic eruption. Which two gases, droplets of sulfuric acid, are formed when sulfur dioxide reacts with water in the upper atmosphere? These droplets reflect ultraviolet radiation from the sun back into the atmosphere. In volcanic eruption in Indonesia in 1815, large amount of both carbon dioxide and sulfur dioxide were released. Okay, so basically you need to assess the effect of these two gases. One is sulfur dioxide and the other is carbon dioxide on global temperatures after the volcanic eruption. So first we will discuss on the role of carbon dioxide, and you know carbon dioxide is a greenhouse gas. And it absorbs the ultraviolet radiations and causes a rise in temperature and results in global warming basically. It causes global warming, which causes the increase in temperature. So global warming major cause is carbon dioxide. And now you need to assess the effect of both gases on the global temperatures after the volcanic eruption. So, you know, droplets of sulfuric acid are formed when sulfur dioxide reacts with water in the upper atmosphere. These droplets reflect ultraviolet radiation from the sun back into the surface. So the sulfuric acid which is forming, the sulfuric acid causes global cooling basically, because it reflects back the ultraviolet radiation of the sun. So it causes a drop in temperature. The effect of sulfur dioxide is greater. Why? Than that of carbon dioxide. Why? Because the temperature were lower after the eruption.